Okay, this first note card is number 73. And the title is Tangents. And this has nothing to do with sine cosine tangent. The word tangent here doesn't have to do with a right triangle. It has to do with a circle. A tangent is a line that intersects a circle exactly once. A line that intersects a circle exactly once. So here's a circle. If you had a line out here, it wouldn't hit the circle at all. If you had a line here, it would hit the circle twice. So I'm talking about the line in the right place so that it just barely hits the circle once. It's kind of hard to draw. So that's called a tangent line because it just hits the circle once. Okay, that point where it hits is called the point of tangency. The place where the tangent line hits the circle the one time is called the point of tangency. Now, before I get too much into what we're doing today, the new stuff, I want to remind you about old stuff. So don't write this down. This is old. This angle, what kind of an angle is this? Central angle, good. The reason it's called a central angle is because the vertex is at the center. And then this angle, we just learned this on Friday, so maybe you don't know this is good. It's called an inscribed angle because the point, the vertex, is on the edge of the circle. So this is an inscribed angle, this is a central angle. If this angle is 40 degrees, how big is this arc? Yeah, 40 degrees, because the central angle and the arc are always the same number of degrees. If this angle is 40 degrees, how big is this arc? Yeah, Charlie? 80, because the arc is always twice as big as the inscribed angle. Everybody okay with these two pictures? That's old stuff. All right, back to the new stuff. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So over here I need to draw a radius to show you, and I don't mean just any old radius. This one isn't the one I'm talking about. This one isn't the one I'm talking about. I'm talking about the radius to the point of tangency. So that radius right there. And then you got to ignore the circle and that's a right angle. The tangent line and the radius are perpendicular to each other. So that's a right angle right there. Okay? Then the other idea on this note card is if two segments from the same exterior point So if two segments from the same exterior point are tangent to a circle, if two segments from the same exterior point are tangent to a circle, what are you saying? That what makes a right triangle? Well, I mean, when we have a tangent and a radius, that's not enough lines for a triangle. Well, this word says that. So we already did write it. But we didn't say it in the way you were thinking of it. You with me? So it was a good question, but in my head, I had already written it down. Good. Okay, so if two segments from the same exterior point are tangent to a circle, so let's draw this. Here's a circle. And when I'm talking about an exterior point, that means that I want to point outside the circle. An interior point would be a point inside the circle. So I've got an exterior point, and I'm supposed to draw two segments tangent to the circle from there. So the first one's going to go this way. So there's the first line segment that's tangent to the circle. And then the next one's going to go this way. So there's the next line segment that's tangent to the circle. So I have two segments from the same exterior point that are tangent to the circle. And what turns out is then they are congruent. So put a tick mark here and put a tick mark there. That means they're congruent. All right, that's it for that one. Now 74. Title here is Secants and Tangents. Is secants and tangents. So the first fact on this note card talks about when two chords intersect inside a circle. When two chords intersect inside a circle. So here's a circle. What's a chord again? What's a chord of a circle? It's a line segment that goes from a point on the edge to another point on the edge. So here's a point on the edge, here's another point on the edge. If you connect those, that's called a chord. For this idea, I'm supposed to have two chords intersecting inside the circle. So there's another chord. So I've got the situation now. Two chords intersecting inside the circle. Now this idea is about the measurements of the lengths. So let's say I measured from there to there and I got 6 inches. And then let's say I measured from there to there and I got 4. And then what you do is you take those numbers and you multiply them together. So 6 times 4. But I want this idea to work for any situation. So instead of calling that 6 and 4, I'm going to call it A and B. So what you do is you take A times B. So then I'm going to measure from here to here and call that C. And I'm going to measure from there to there and call that D. So you take C times D. And it turns out that A times B is going to equal C times D. Yes?
So we're saying like C times D, and the answer of that equals the same like A times B. Not just like A equals C and the same. Like 4, like both A and C are 4, or it could be different.
Could be different. It's just that after you multiply the numbers together, then it's equal, not the individual numbers. Good.
Okay.
So back to my 4 and my 6. If the A was 6 and the B was 4, that would multiply out to be 24.
Yeah.
And then this could be 3 and 8.
Okay.
It wouldn't have to be that the actual numbers were equal. Yeah, great question. So if that was 3 and that was 8, it would multiply out to 24. And if that was 6 and that was 4, then it would multiply out to be 24. So that would work for this situation. It's just one possible example. Yeah, but he asked a great question because a lot of times people look at this and they think, oh, does that mean A has to be equal to C? And it's not. It doesn't necessarily have to. All right, there's a vocabulary word here, secant. A secant is a line that intersects a circle at exactly 2 points. A line that intersects a circle exactly twice. Secant, a line that intersects a circle exactly twice. So if I drew a line here, that wouldn't hit the circle at all. If I drew a line here, it would hit the circle once. But then if I draw a line here, it hits the circle twice, so that's called a secant line. What's it called if it just hits the circle once? A tangent line. Good. So if it doesn't hit it at all, it doesn't have a name. But if it hits it once, it's called a tangent line. But then if it hits it twice, it's called a secant line. When two secants intersect outside of a circle, two secants intersect outside a circle. So here's a circle. And I've got to draw two secant lines. So here's one. And then I could draw another one here, but it wouldn't be intersecting the other one. So I want it to intersect this other one. So now I have two secant lines that are intersecting right there outside the circle. So this theorem has to do with measurements as well. So let's measure from there to there, and I'm going to call that J. Maybe it's 10 inches. And then measure from here to here, and I'm going to call that K. Maybe it's 8 inches. So what you do on this one is you take the outside times the total. So J times J plus K. The letters always confuse people, so let's go back to the numbers. So let's pretend J was 10 and K is 8. So you would take 10 times 18, because the 10 plus 8 is 18. All right, now this one here, let's call that M. And this one, let's call that N. So you do the same thing. You take the outside length times the total. So M times M plus N. And it turns out that those are equal. The outside times the total for this secant line is equal to the outside times the total for this secant line. Last one. When a secant and a tangent intersect outside a circle, when a secant and a tangent intersect outside a circle, back to my circle. I'm going to draw a secant line. And then from here, a tangent line. So there I've got it. A secant line and a tangent line intersecting right there outside the circle. This one has to do with lengths as well. So let's call this length G. Let's call this length H. And then call this length E. So maybe G is 5 inches. Maybe H is 7 inches. It's the length there. So you still do outside times total. So G times G plus H. And what it equals is E squared. So for the tangent line, you just take that number times itself. That's it for note cards. Paper is called Geometry 9.5. Here's the picture for number 3. So this kind of connects last chapter with this chapter because it's got a triangle in it. That's what we were talking about last chapter. And then it has a circle in it. So let's look at the triangle first. What kind of a triangle is it? Yeah.
An isosceles triangle?
I don't think two of the sides are the same. Were you feeling like this was 20?
I was just looking at the triangle, maybe that's why. If the triangle lights up and not really the numbers.
Okay. Well, if it's going to be isosceles, it has to have two equal sides.
Yeah.
So I guess it's possible that this is 20, but we don't have that information. So we're not sure whether it's isosceles or not. Good. But thanks for being willing to talk, because it gets boring if I'm the only one talking. So, what do you got, Judah? It's a right triangle. How does he know that that's a right triangle? Yeah, Maddie? So because of the tangent line, right? What else? Yeah. Because of the radius. And we had the first thing we talked about today said that the tangent line and the radius are going to make a 90-degree angle. So they didn't have to mark this as 90 because we know that the radius and the tangent line will make a 90. So that's a right triangle. And when you have a right triangle, there's a lot of formulas that you can use. Sine, cosine, and tangent work on right triangles. And then also Pythagorean Theorem. This time we're going to use Pythagorean Theorem. So we got 15 squared plus 20 squared equals x squared. X is the hypotenuse, right? Then 225 plus 400 is 625. And then you just have to take the square root. Square root of 625 is 25. Here's the picture for number 4. Another circle. This one's not too bad at all. What's x? Yeah, Taylor? 14. Awesome. So just write down x equals 14. How do we know that x is 14? Yeah, Taylor? So we had two tangent lines, and they're from the same exterior point. And the second idea we wrote down today said, if you have two tangent lines from the same exterior point, they're going to be congruent lengths. So that's why the x is 14. All right, now number 9. My handwriting's kind of bad. That's an A. So we have to write an equation to try to figure out what A is. Yeah, Maddie?
I'm not sure this is right, but is it 10 times A equals 6 times 5?
That is right. Good. So you multiply the 10 times A. And you multiply the 6 times 5. And this is, the situation here is there's two chords. And when you have two chords, the piece times the piece equals the other two pieces multiplied. So this says 10A equals 30, because 6 times 5 is 30. And then you just divide by 10. So the A comes out to 30. This is an A again. They start looking like 9, sorry. So what do you do in this situation? Yes, Judah?
A times 2 equals 4 squared.
Close. You're going to square the 4. He's right on that.
Or 2 times parentheses 2 plus A.
Yeah, you do the outside times the total. So the outside is 2, and the total is 2 plus A. The way I think about this is outside piece times total. Outside times total. So that side will come out to 16. Then you distribute this 2. And subtract the 4. So it ends up being A equals 6.